calculus. Calculus actually deals with change. Okay, so calculus, every time we're talking about calculus or studying calculus, we're talking about change. And in this introductory week of calculus, first of all, calculus is divided into two main sections. Something called differential calculus and something called integral calculus. And throughout the course, we will learn different formulas and ways of dealing with differentiation and integration. And we will be looking at two functions and comparing two functions, basically. So calculus deals with change, and in particular, looking at functions. If we look at one function, and we talk about the change of that function, we're talking about differentiation. We could take one function, function 1, and differentiate it to get function 2, or we could take functions to start with function 2 and integrate it to end up with function 1. Okay, so first of all, we need to talk about this idea of limits. So what is a limit? So a limit is dealing with approaching a number. So for example, we might see something like this. The limit as x approaches 2 of x squared. Now if we think about this, the limit as x approaches 2, what is x squared actually going to equal? So we could think about, okay, as x approaches 2, so in other words, if x is 1, okay, then x squared equals 1. So approaching 2, if x is 1.5, x squared equals 2.25. If x is 1.75, x squared will have another value. I can't think what that is right off the top of my head, but we could calculate it. And then we could keep going and going and going. If x is 1.9, x squared equals a certain number. If x is 1.99, x squared equals a certain number. If x is 1.9999999, x squared will equal a certain number. Okay, now we're thinking about the limit as x approaches 2. And here we're coming down, as we come down this way, we're approaching 2. 1.9999999 is actually very, very close to 2. And so x squared, this number here, is going to be very close to 4. Okay, we could look at it coming from the other direction as well. So this is coming from the negative direction. Okay, so we're coming from, if we were looking at a number line, and the number 2 is here. Right now, what we've done here is we've looked at as x approaches 2 from the negative side of the number line. Okay, now let's look at as x approaches 2 from the positive side of the number line. So for example, we could say if x equals 3, then x squared will be 9. If x equals 2.5, that's getting closer to 2, then x squared will be a certain number. If x is equal to 2.2, x squared will be a closer number. If x equals 2.1, x squared will be a certain number. We could fill these numbers in and calculate them. But we all know what's going to happen here. We're getting closer and closer and closer to the number 4. Ooh, before over here I said we're getting closer to 2. That's not true. X squared is getting closer and closer to 4. So as x is approaching 2, x squared is getting closer and closer to 4. Okay, so we could say 2.01. We could say 2.00000001. Then x squared, again, would equal a certain number. Okay, I'm going to take a minute to figure out what these numbers are. Okay, so now I've taken the time to fill in what each of those numbers equals. All right, so this is a very important concept in calculus, limits. As x approaches 2 in this function, x squared, as x approaches 2 from the negative side, okay, so coming from this side, what is happening? X squared is getting closer and closer and closer to the number 4. As x is approaching 2 from the positive side, so getting smaller and smaller and smaller, but closer to 2, then x squared, again, is getting closer and closer and closer as we come down this way to the number 4. Okay, this is the basic description of a limit. Let's look at another one. We can take a look at the limit as x approaches 0 of x squared plus 3x all over x. Okay, now we can use some algebra here. We can simplify this by saying, okay, this is equal to the limit of x as x approaches 0. We can factor out an x plus 3, and x. Okay, now we know that x cannot equal 0 here. Because we can't divide by 0. Okay, so it makes sense that we look at as x approaches 0. Now we need to look at as x approaches 0 from the negative side, as x approaches 0 from the positive side. Okay, so if x is not 0, it will never be undefined, and therefore this is the same as the limit of as x approaches 0, x plus 3. So what will happen to this function as x approaches 0 from the negative side? This function, x plus 3, will get closer and closer and closer to 3. As x approaches 0 from the positive side, so we're looking at number 2, number 1, number 0.5, number 0.4, number 0.3, all the way down to 0.01, 0.001, 0.000001, and so on, then this function equals 3. Okay, so this function, the limit as x approaches 0 of x squared plus 3x all over x actually equals 3. All right, let's look at another one. We've got the limit as x approaches 3 this time of x squared minus 9 all over x subtract 3. All right, so we chose as x approaches 3 for a particular reason, didn't we? As x approaches 3, that makes this function undefined. So again, we can factor. This is a difference of squares, so x plus 3, x minus 3. And of course, the x minus 3 divided by the x minus 3 equals 1, so we can essentially cancel those out. And we have the limit of, as x approaches 3, of x plus 3. Well, we know that that's going to equal 6.